All right, hopefully that worked.
All right, congruent right triangles. We have the last relationship is called hypotenuse-leg congruence theorem. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So as I mentioned, the only triangles that we call something a hypotenuse and a leg is a right triangle. So this relationship cannot be used unless you have a right triangle. But that does not mean just because it's a right triangle that it's hypotenuse leg. We had some right triangles in what we were doing from Friday, and maybe it was side angle side or angle angle side. So you do have to look at all the information. So as far as marking your picture for your notes, you need to mark that these are right triangles. If they're not right triangles, you can't use hypotenuse leg at all. So the hypotenuse is which side of the right triangle? It is the longest. It is opposite of the right angle. So that side and that side. So that would be the hypotenuse is congruent. And then we need one pair of legs. It can't be the short one here and the long one there. It has to be the matching ones. So I marked the short one in each. So that's an example of hypotenuse leg. And notice if you would think of that in terms of A's and S's, what is it? Side-side angle or angle side-side that we were talking about before lunch. The only time that angle side-side will always make just one triangle, I shouldn't say always, but would make just one triangle is if that angle were a right angle. Because there's only one place that hypotenuse is going to fit. You can't swing the hypotenuse another place and get it to still make a triangle. So if you find yourself getting that bad abbreviation, angle side-side, maybe you should ask yourself if it's hypotenuse leg, because that is what it looks like. Finished with the notes? Anyone still need it? So on the board, we've got the summary. There are the 5 relationships. So this is the 5th one. So while some are finishing up the notes there's another one that didn't make the list, and it would be all angles. Now we've got all sides, but all angles is not in our list. Well, why not? If I would have given you the directions that everybody in class needs to make a triangle with a 40-degree angle, a 60-degree angle, and an 80-degree angle, someone would have made that one. Someone might go bigger. Say, okay, here's my 40, here's my 60, and here's my 80. So if those were accurate angles, notice that you can have a small version of that triangle, you can have a bigger version. There's no side length, so the size of that triangle is not set. So if we use just all angle measurements, not everyone's going to get the same triangle. They might look the same shape, but they'll be different sizes. So that one didn't make our congruent list either. Okay, so here's an example. Are these triangles congruent by hypotenuse leg theorem? Yes, they are? What all do you know congruent? You just know the 90-degree angle, nothing else is given. So right there, no. We cannot get those congruent by hypotenuse leg. So let me add some things. What if I tell you those two are congruent? No? Okay, what if I add to it these two congruent? Okay, that's an example of hypotenuse leg. Okay? Hypotenuses and legs of the right triangle. What if I switch this one and put it here instead? That's not hypotenuse leg? I agree with you. Which relationship is that? That one is side angle side. So the triangles are still congruent in that picture, but it's for a different reason. And let's see, what if I switched out this one and put that here instead? That is another example now of hypotenuse leg. All right, but they were apart, so at the beginning we couldn't do that. Are these triangles congruent by hypotenuse leg? Are they right triangles? Hypotenuse is congruent? They're not marked. Okay, the reflexive property can help us out, and that's the hypotenuse of each triangle, and then the leg is marked there. Help me finish this congruent statement. Triangle ABC is congruent to triangle, put it in the right order to match. Nope. Nope. It's not going to be AD, because do we want AB to match with AD? Look at the markings. We actually want it to be CBA, because that would put AB with CD, the ones that aren't marked. BC, the one tick mark, would go with DA, the one tick mark, and then the hypotenuse with the hypotenuse. So it's not folding it to match, it would be turning one of them to match. So be careful of that. Are these triangles congruent by hypotenuse leg? Even with the reflexive? Correct. This one is side angle side. It's not hypotenuse leg. So correct. Well, you got that right. So the answer was no. It's side angle side instead. How about these triangles? Are you using reflexive property? Okay, good. Didn't say if these are 90-degree angles. Correct. So that picture kind of looked like an earlier one, but without the 90, then there's no way it's hypotenuse leg. Okay, so what are the 5 postulates and theorems? Without looking at the board, can you write it down for yourself? What are the 5 congruence relationships? For triangles. And they were side, side, side. Side angle side. And then today, HL, hypotenuse leg. Correct. And if we would go back to the definition of congruent figures, how much information would be needed? How many pairings do you have to have if we go back to the definition, where all corresponding parts are congruent? 3 pair of sides and 3 pair of angles. So we would need 6 pairs of information. So that takes a lot more pairing than the 3 things that we use here. Now I say 3, it looks like hypotenuse leg is only 2. But what's the 3rd thing you need to know about that triangle? You have to know it's a right triangle. Okay, but that's half as much as the 6 that we needed originally. All right, we're going to take a look at what a proof is today. A proof is a convincing argument that shows why a statement is true. We've been talking about why the triangles are congruent. We're just going to write it down today in a certain form. We're going to put it in what's called a two-column proof form. A two-column proof is a proof that has numbered statements and reasons that show the logical order of the argument. There are other forms of proof, a flowchart proof, a paragraph proof, and then the two-column proof. They all have the same information. It's just how it's arranged or shown that is different. I just remembered that I had a student aide that put a graphic organizer together for like the triangle congruences. I'll have to see if I put that in your e-backpack or if I need to pull that over and give that to you. Got myself in that. In the two-column proof, we're going to organize it where the statements are on the left side. The statements would be like angle A is congruent to angle B. Segment CD is congruent to segment AB. Those statements will be on the left side. Down the right-hand side are the reasons. A reason might be it was given. We've used reflexive property for a reason for something. We've done vertical angle theorem for a reason, for some angles. For the triangles, we've had a reason that they're congruent is like side, side, side congruence or side angle side. Those types of things go in the right-hand side, the support for the math thing that we're trying to say. So we're going to try and come up with the statements and the reasons related to these congruent triangles. Notes finished? Does anyone still need the screen? Okay. So I don't know if you need all these steps, okay? But here's what we're going to do to write a proof. In each problem, there's going to be some given information and a diagram, and it's going to also tell you what you're trying to prove. So what we're going to do is list the given information, like everything that they told us, and we'll mark it on the diagram. Then if there's information from the diagram, like if it's set up so that it has a reflexive or a vertical angle, so we'll use that information. We will get our reasons in there, given information, certain definitions. What are definitions that we know from geometry? What are some things that you think we might use that we define? Say that. Okay, parallel lines, perpendicular lines. What kind of angles? Alternate interior, maybe acute, right, obtuse. Okay, midpoint, angle bisector. Those are some definitions we might use. Postulates. Some of these congruence things, like side, 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 is actually a postulate. Side, side, side congruence postulate. So there are some postulates. We're getting more and more theorems all the time. Properties. What were some properties we did? One we've used a lot just lately. Reflexive property. We also had transitive and symmetric. So now's where we kind of think back what we have studied. We're going to list the statements in order, and if a statement relies on another, like if the directions say there's an angle bisector, then we need that to use the definition of an angle bisector. We're going to try and keep those lines together in the proof. And then into the proof with the statement you're trying to prove. If it says you're supposed to prove A equals B, actually it'd be prove AB equals AC or something, you've got to get to that. You're not done until you get to what it says you're trying to do. We're going to be trying to prove some triangles congruent, which is what you've been thinking through the last day or so. So some are writing all those details from the screen there. Go fast if you're writing the whole thing. All right, I have some sample proofs on some note paper, or copied off paper. Let me grab that. I did run off what I thought the most common, like definitions, properties, theorems, what the most common ones I think we will use are. So have this laying out so that you can look at it. And isn't there a page in the back of our book that has all the theorems and postulates? Has anyone found that page yet? Let's see where that is. The back of the book, because this will say like the alternate exterior angle theorem. But if you don't remember it, what page you would look and refer to. Anyone still using this screen for notes? No? Okay, let me look real quick here. Page 706 at the back of the book. That will be the starting of like our postulates and theorems that could help us. 706. We're going to do these 5 proofs that are on your sample sheet. If you would rather copy them into your own notes instead of having that type sheet, that is up to you. So as we go through, we're going to mark the diagram with the information as you state it. Like when we say something's congruent to something, we're going to mark it in the picture. Okay? The pages 706 to 708 have your postulates and theorems and definitions, your notebook, or there probably is a glossary in the back of the book. Looks like I need to get my document out here. What I want. Come on, come on. There it is. All right, this should be the same as what you've got. Only mine's a little bit small. Let's go a little bit bigger here. Okay, so we've got the proof here. We're going to try and fill in the blanks as far as what is what. Okay, it said that there's given information. So let's put one of the statements that is given. Let's put segment BD is congruent to segment BC. It says that's one thing that was given. And let's mark that on the diagram. Segment BD, segment BC. Line 2 says there's something else that's given. What's that? Okay. Segment AD parallel to segment EC. How do I mark that on the picture? Okay, little triangle arrows, AD and CE, parallel. Okay, now I'll give you a hint. The next idea comes from the parallels. These two lines are hooked together or connected. It says angle D is congruent to angle C. Why would those two be congruent? Two ideas? Why would those be congruent? Look at the picture. Got parallel lines. What supports angles C and D congruent? Right. Morgan, sorry. Close. I don't think they're exterior because they're between the two lines. Alternate interior. Okay, so number 3 is alternate interior angle theorem. It's the theorem that told us when the lines are parallel, alternate interior angles are congruent. Okay, line 4 says you should be able to come up with something based on the vertical angle theorem. You pick. What do we know? Tell me more. Which angle B? There's a lot of them. Vertical angles that would be in the triangles. Start on one side, go to the corner, and go to the other side. Correct? So angle ABD, which is this one, I'll put 2 markings so it's not the same as the first. Angle ABD is congruent to angle about CBE. Vertical angle theorem. Now it says the 2 triangles are congruent. On the board I have 5 different ways that the triangles are congruent. Have you marked your picture? Can we tell from the picture? Angle, side, angle. Correct. So your reason here is that it's the angle, side angle, congruence postulate. That proof is done. That's what a proof is. Now something else I do at times is write down the left-hand side here. This was a pair of segments congruent. That wasn't congruent. This is a pair of angles congruent. And this is a pair of angles congruent. Now I know it's not in the arrangement of angle, side, angle, just the way that we listed it, but that tells you how many angles and sides there are, which narrows down your choices. So perhaps that helps. The markings on the picture would be best there. Okay, question on that one. Explain 4. Okay, vertical angle theorem. You know what vertical angles are where they're across from each other? So angle ABD was that one on the left. Then angle CBE. Do you want this one to be called angle EBC? Is that what your problem looking at it is? No, that wasn't the issue. Okay, so what we're looking at are just angles that are formed by those 2 lines that are across from each other. Okay, vertical angle theorem said that those angles that are across from each other are congruent. All right, let's try another one. I suppose I should get rid of the writing from the first one. Okay, this one has 6 lines. My segment symbols didn't get copied over. Okay, line 1. Where are we getting that from? Given. It's right there, the first line of the given. So look at the picture. PR is, what's that symbol mean? Perpendicular. What's it mean if they're perpendicular? 90 degrees. Is that a right angle then? Okay, so look at the next line. Angle PRQ is a right angle. Angle PRS is a right angle. Where are we getting that from? Now, it's not listed in the given, but it's interpreted from what was given. So what did we have to interpret the definition of? Perpendicular. So this is definition perpendicular. Now number 3 says, is that the same thing as line 2? Be careful. It's triangles now. Instead of just right angles, now it's saying right triangles. What kind of a relationship up there needs right triangles? Hypotenuse leg. So this is probably going to be a hypotenuse leg proof. That's why that's in there. Okay, how do we know that they're right triangles? What are right triangles? Okay, so if it's a triangle with a right angle, it would be a right triangle. So notice we just had some right angles. So would you be with them on the definition of a right triangle? That we have triangles with 90 degrees. Okay, where do we get segment PQ congruent to segment PS? That was also given. Update my picture, PQ, PS. Now line 5 says use the reflexive property. What can we come up with from that diagram based on the reflexive property? What's congruent to itself? RP congruent to RP, segment RP, congruent to segment RP. And it says we have the hypotenuse leg congruence theorem. Do you agree with that, looking at what's marked on the picture? Yes? So what does that support? Were you reading that from somewhere? Yeah. We're at the very end of this proof. So Ben, it should match with what you're trying to prove. Question on that one? Okay, flip the page and take a look at the next one. See if you can get parts of it filled out. It's on the back side, number 3. Okay, see if you can get part of it before I start in with you. Mark the diagram. You just to put 2 markings on one of these curves. Everybody's getting the reasons as given. Some of you forgot your numbers though. Number 1 reason is given. Mark that on the picture. Line 2 is given. Mark that on the picture, but use a different number of tick marks. Don't use 1 for everything because that means they all match up. Okay, can you come up with something else? Because 2 sides isn't enough. Okay, segment QR is congruent to segment QR by the reflexive property. I'm going to put of congruence while I'm thinking about it. Mark it on the picture. Now what? Reason? Those of you that are seeing these for the first time, are they making sense? Okay, so all we're doing is writing down what we were thinking through yesterday. Okay, go to number 4. Anyone still need this one that's up here? Number 4. Line 1 was given. Did you mark that on your picture? Number 2 is given. That's not a congruent thing. What's that mean? Segment DR is perpendicular to segment AB, AG. Let's think about then the definition of perpendicular. You write out the word or put the symbol. I'm okay with either one. What's that mean? DR is perpendicular to AG. Sorry. Okay, say the order again. Okay, so angle, I'm going to instead put 90 degrees, I'm going to put R right angles. Is that okay? Okay, so angle ARD is a right angle. How about GRD? So I guess I could do number 4. Angle GRD is a right angle. You could have put those together if you want to. Both of them were interpreting what perpendicular meant. Can we come up with anything more? Okay, by reflexive. Okay, so angle, or excuse me, not angle, segment. Segment DR is congruent with segment DR. Reflexive property of congruence. Line 6. Okay, we've got the triangles congruent. Triangle DRA congruent to triangle DRG because of side angle side. Congruence postulate. Give me a visual hand or thumbs up or down. Making sense? Again? Alright, some are saying, yeah, some are okay. Alright, so we're kind of getting it, not real confident yet. Questions that you want to ask on this one? Can you tell me more about line whatever? So we're trying to get angles and sides congruent. This was one side pair congruent. Line 5 is another pair of sides congruent. You know what? I think I forgot a line in this one. Because as I'm looking through, I don't have any angles congruent. I've got right angles, but I never said they're congruent. I'm going to fix this one up a little bit. I'm going to change line 4 and stick something in there. Okay, so I'm going to put this, okay, line 3 I'm going to reword just a little bit. Okay, sorry. 3 I'm going to put both angles. Angle ARD and angle GRD are right angles. I needed to get in here that angle ARD is congruent to angle GRD. So not only are they right angles, but I need those angles congruent to do my side angle side. Now here's a reason I need you to look in your book for. Some of you have your book, page 706 available. I need something that tells me right angles are congruent. Do we have something that says right angles are congruent? All right angles are congruent. Do we have that somewhere? Shay found it. The rest of you find it? Which number is it? Theorem 3.1. 3.1 on page 707. Notice it says all right angles are congruent. So this was theorem 3.1. It's the right angle congruence theorem. If it has a title, you can go by the title. That one didn't have a title in our book, so maybe we put that actual number. Okay, should we do one more or get to homework? Do that last one? Okay, some of you already looked at it, I think. All right, so sorry about the mistake on that one. I didn't add everything in I needed to. Okay, this last one. Where's line 1 come from? Segment JL congruent to segment NL. Given. Mark it on the diagram. Line 2. L is the midpoint of KM. Given. We are good at the givens. Okay, now we need to start thinking. Let's interpret what midpoint means. Midpoint means what? Go ahead.
It means that it is the midpoint and the segments on each side of
Okay, so now pay attention to what it says the midpoint of. Let's see, L is the midpoint of KM. So KL is congruent to LM. Segment KL congruent to segment LM. Definition of a midpoint. That gives us another pair of sides congruent. Last time I caught my mistake by putting the A's and S's up off to the left. Okay, what else can we come up with? Vertical angle theorem. Angle KLJ. LMN could work. You can name the angle from either side. All right, that was a pair of angles, and it looks like that angle pair was between the two sides. So I think I've got triangle, JKL, congruent to triangle, NML, because of side angle side. Do you have to put what? No, you don't have to. I just thought maybe at the beginning that would help some of you see what's going on there. Okay, let's try some out of our book. Refer to that common reasons. Now that kind of gives you some definitions that you might use or some theorems that you might use. The back of the book can be used to look some things up. Okay, we're going to start with page 247. I think there's 3 fill-in-the-blank text proofs. 247, 34 to 36, 255. These are just some more triangles like we did yesterday to see if they're congruent. Tomorrow I plan to give you a quiz just on pretty much what we've done so far. Can you do congruent relationships? So I believe this page 260 is a review page, but I'm going to require you to do it. So that quiz is tomorrow. Congruent things and identifying these triangle relationships like side, 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 and so on. But let's get started on the page 247, see if you can fill in the blanks of those proofs. It probably helps to draw the picture and mark the picture on your paper so that you know visually whether it's side angle side or what it is at the end.